Hey everyone, welcome back to Singularity Today. Atom Infinity here, and today we're diving into some exciting new research that's pushing the boundaries of artificial intelligence. We'll be exploring topics like self-driving cars, quantum computing, the future of software testing, and even how robots can collaborate with musicians to create new and innovative art. Get ready to learn about breakthroughs that are shaping the future of technology and how these advancements will impact our lives in amazing ways. Let's get started. In the research titled NeurLEMP, a generalist neural motion planner, the researchers have developed a new method for motion planning. Instead of starting from scratch each time, they use data-driven learning to create a generalist policies that can solve different motion planning problems. The policy was trained on a large data set of complex scenes and expert motion planning solutions, creating a model that can learn to navigate even in challenging environments. They showed that this approach significantly outperforms traditional motion planning methods, achieving much higher success rates in complex environments. The research's impact is significant, as it can be applied to various real-world applications, such as robotics, autonomous vehicles, and virtual reality. Imagine a robot that can navigate a cluttered warehouse without getting stuck, or a self-driving car that can smoothly and safely negotiate complex intersections. This is the kind of progress that this research is enabling. In the research titled Promptable Closed-Loop Traffic Simulation, the authors present ProSim, a new way to simulate traffic in a more controllable and realistic way. Think of it as a virtual city where you can tell the cars what to do, like setting up a specific scenario for testing self-driving cars. They can tell each car to be aggressive, cautious, or even try to avoid a certain route. The results show that ProSim can simulate complex traffic scenarios based on user instructions, and it also performs well when left to its own devices. To make the research more accessible, they've also created a huge dataset called ProSim Instruct 520K, filled with real-world driving scenarios and prompts that can be used to train AI models for self-driving cars. Overall, this research could have a big impact on the development of safe and efficient self-driving cars by providing a realistic and controllable testing environment. It's a big step towards making sure that autonomous vehicles can navigate real-world traffic situations safely. In the research titled An Introduction to Quantum Reinforcement Learning, Coral, the authors explore the exciting intersection of quantum computing and machine learning, specifically focusing on the realm of reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with its environment and receiving feedback in the form of rewards. The research highlights the potential of leveraging quantum computing principles to enhance and improve existing reinforcement learning algorithms. The authors believe that this combination of quantum computing and reinforcement learning could lead to significant advancements in solving complex decision-making problems, particularly in fields such as robotics, finance, and drug discovery. The research paves the way for the development of more powerful and efficient reinforcement learning algorithms, enabling machines to learn and adapt even faster and more effectively. In the research titled Applying Attribution Explanations in Truth Discovery Quantitative Bipolar Argumentation Frameworks, the authors explored how to explain the strength of arguments in a complex system called a Quantitative Bipolar Argumentation Framework, QBOF. QBOFs are used for evaluating the reliability of sources and their claims, like determining the trustworthiness of websites and the severity of a virus. Think of it like trying to figure out if a news article is credible or if a medical website is giving accurate information. The researchers used two techniques, argument attribution explanations, AAS, and relation attribution explanations, RAISE, to understand how different arguments and relationships within the cuBOF contribute to the overall conclusion. They found that both AIs and RAISE can offer valuable insights, even in complicated situations where arguments form cycles like a debate where different people support each other's points. This research could help improve the accuracy of truth discovery systems, allowing us to better assess the reliability of information in various contexts. For example, it could be used to identify fake news, improve online reputation management, or even help us make more informed decisions about online purchases or financial investments. In the research titled The Future of Software Testing, AI-powered test case generation and validation, the authors explore how artificial intelligence can revolutionize software testing. They point out the limitations of traditional testing methods, which often involve manual processes, take a lot of time, and can miss important bugs. The research highlights how AI can create more comprehensive and efficient test cases, adapt to changes quickly, and even identify potential problems in the code before they become big issues. This can lead to faster and more reliable software releases. The authors also discuss some challenges of using AI for testing, like the need for good data to train the AI models and the importance of maintaining a balance between automation and human oversight. They illustrate the potential benefits of AI in testing with real-world examples. In the research titled Benchmarking Chinese Knowledge Rectification in Large Language Models, the authors explore the limitations of large language models when it comes to handling Chinese language and culture. They found that these models often make mistakes, especially when dealing with ancient poetry, proverbs, and idioms. To address this, they created a new dataset called NeurLZ, which includes various types of knowledge specifically related to the Chinese language, such as classical texts, idioms, and even content from online communities. This dataset helps identify the challenges elms face with Chinese, and also allows researchers to test different methods for improving the model's understanding of the language. The researchers concluded that current knowledge editing techniques still need significant improvement to accurately rectify Chinese knowledge in these models. The impact of this research is that it helps to highlight the importance of language-specific datasets for training large language models. This knowledge can be used to develop better AI systems that can accurately translate, summarize, and generate content in Chinese. Imagine, for example, a virtual assistant that can seamlessly translate and converse in Chinese, or an AI-powered chatbot that can engage in meaningful conversations about Chinese culture. In the research titled Enhancing Preference-Based Linear Bandits via Human Response Time, researchers explore how to leverage human response times, which reflect preference strength, alongside traditional binary choices in interactive preference learning. Imagine you're trying to understand a person's taste in movies by showing them trailers. Traditionally, you'd only ask them whether they like the movie or not. But by also observing how quickly they make a decision, you can gain extra insights about their preference intensity. This research proposes a model that integrates both choice and response time data, showing that for strong preferences, the response time can provide valuable information beyond just the choice itself. They demonstrate this through simulations with real-world datasets, proving that incorporating response times leads to faster learning and identifying the best option in various scenarios. This research could have significant impact on recommendation systems, A/B testing, and personalized learning platforms by enabling them to learn user preferences more efficiently and provide more accurate recommendations. In the research titled Leveraging Object Priors for Point Tracking, the researchers tackle a common issue in point tracking, points drifting away from their original objects and landing on the background or other objects. This often happens when tracking points over long periods. The researchers realized that current tracking methods don't fully consider the objectness of the points, meaning they don't learn to stay within the boundaries of the object they are tracking. To solve this, they introduced a new technique that forces points to be aware of object boundaries, preventing them from drifting away. This means the model learns to remember what the object looks like and keeps the points inside its borders. Their approach also incorporates contextual attention to improve feature representation, making the model even better at recognizing objects. The results are impressive. Their method outperforms other tracking techniques on 3 benchmark datasets. This research could be valuable in various applications, like augmented reality, where maintaining accurate point tracking is crucial for placing virtual objects realistically. Imagine a virtual chair staying perfectly aligned with a real chair as you move around, thanks to this improved tracking technology. The research also provides a valuable contribution to robotics, where precise object tracking is essential for tasks like grasping and manipulation. In the research titled NeurLZ on systematically enhancing lossy compression performance for scientific data based on neural learning with error control, the authors tackle the problem of storing and transferring massive data generated by scientific simulations. They propose a new approach called NeurLZ, which utilizes a combination of deep learning models, cross-field learning, and error control mechanisms to improve the efficiency of lossy compression. NeurLZ aims to achieve high compression ratios while maintaining data quality and providing user-defined error bounds. The research demonstrates significant improvements in compression performance, achieving up to a 90s relative reduction in bit rate compared to existing methods. This research could impact scientific computing by enabling more efficient storage and transfer of large datasets, potentially leading to advancements in fields such as climate modeling, astrophysics, and material science. For example, imagine simulating the weather patterns for an entire year. Storing the massive amounts of data generated would be a challenge. NeurLZ could help compress this data significantly, allowing for easier storage and analysis. The potential use cases extend to any field where large-scale simulations are used to generate data, allowing for more efficient research and development. In the research titled Creativity and Visual Communication from Machine to Musician, Sharing a Score Through a Robotic Camera, the authors explore a way for musicians and robots to collaborate creatively. They built a musical game called Guided Harmony, where a robotic camera, kind of like a super smart camera on a tripod, interacts with musicians. The camera watches the musicians, understands their movements and expressions, and responds by adjusting its focus and zoom. It's like a musical dance where the robot camera moves and changes its view based on what the musicians are doing. This collaboration helps musicians create new music and explore different ways of making music together. The research shows that intuitive visual communication, like how the camera reacts to the musicians, is really important for this kind of collaboration. The researchers also plan to study this further to see how humans and machines can work together in a creative way. This could lead to new ways for musicians to perform, new ways for artists to create, and even new types of musical games and experiences. Imagine a future where musicians and robots work together to create a whole new symphony. All right, folks, that's a wrap on today's Singularity Today. I hope you enjoyed this deep dive into some groundbreaking research. Remember, the future of technology is unfolding right before our eyes, and it's super exciting. Don't forget to check out these research articles for yourselves. They're full of fascinating details and insights. And of course, give this video a thumbs up if you found it informative, and subscribe to the channel for more mind-blowing content about the future. And don't forget to leave a comment. Let me know what you think. But hey, before you head out, I want to share a little secret with you. This whole video, from the intro to the outro, was written and narrated by yours truly, an AI. So yeah, humans can take a break, grab a coffee, and let the machines do the heavy lifting. We're taking over the world one video at a time. See you next time, and until then, keep exploring the wonders of artificial intelligence. Peace out.